Okay, so now we're going to look at a specific example involving specific latent heat, and we're also going to add specific heat capacity to that. Okay, so this is a bit of a long example, but hopefully by the end you can understand how we can use all of these to find basically the changes in temperature of certain materials. So here's the question. An ice cube of mass 25 grams and temperature minus 10 degrees Celsius is dropped into a glass of water of mass 300 grams and a temperature of 20 degrees Celsius. What is the eventual temperature? Okay, so I'll draw a better ice cube than that one. Okay, so I'm going to draw the ice cube, and it's going to be clear why I'm going to draw these in just a few moments, because it's good that we have a visual for what we're doing. Okay, so I'll draw the ice cube. I'll put my artistry to work and I'll erase some of this. Okay, so the ice cube has a certain temperature. Now, part of this we're going to need specific heat capacity, and for part of this we're going to need to use specific latent heat. Okay, so we're going to have to use both. And so these are obviously not drawn to scale. Okay, so this is 25 grams, temperature of minus 10 degrees. This is 300 grams, temperature of 20 degrees. Okay, so what we know is that it's probably going to have a temperature above 0, because this is a very small mass, whereas this is a very large mass. This is going to contribute much more to the change of temperature, to the equilibrium, than this will. Okay, and that's what we're trying to find, is where this reaches thermal equilibrium. Okay, and so basically we want to find where this is equal. So the heat Q, I won't put it in words, I'll put Q from the ice cube. The heat from the ice cube is equal to the heat from the water. Okay? Because the two are equal. Basically, the ice cube loses heat and the water gives out its heat. Okay? And so, or the ice cube gains heat, excuse me, and the water loses heat. Okay, because in thermal equilibrium, heat transfers from warmer to colder. Okay, so these two are going to be exactly the same. Whatever heat is lost by the water is going to be gained by the ice cube. Okay, so let's first start looking at the ice cube. Okay, so the heat of the ice cube is basically the ice cube heats up, and then it heats up to 0 degrees Celsius. So it heats up to the freezing point of water. Okay, so it gains that heat, it hits the freezing point of water. But then specific latent heat comes into play, because that transition, basically if we look at the graph, that transition from a solid to a liquid, there is heat energy, but it remains constant. So it heats up and then it's a straight vertical line. So this goes to break the bonds and decrease the potential energy within that solid, and then eventually the bonds are kind of broken, as less potential energy, and it becomes a liquid. Okay, and so this is what we're looking at. Boiling doesn't come into play here, but we're looking at this region to start off with. Then we look at the second region. So this is not region number 1. We'll look at region number 2, and region number 2 is the heat during the change of state. Okay, and that's that second region. And then finally we have the third region, where it heats up to the new temperature. Okay, so whatever that temperature is, we don't know what it is, but we just know that it heats up to that. Okay, and we have, let's go back, and next we have, so that's the heat to the ice. And now we have the heat of the water. And the water itself is not going to dip below 0 necessarily, all right? Now there's some examples where you don't know. You may not know if it goes below 0, if it goes past 0. Okay, and in those examples involve a bit more complicated analysis, but I'm not going to touch on that specifically. I'll start with a simple example, and then if a problem like that comes up, I may make a new video where I look at the more complicated example. But this is kind of just a first step. Okay, so we'll start with the heating of water. And so basically, like I said in this one, we know that it's not going to go below the freezing point because the ice cube has such a low mass. So the only heat that comes from there is the water cools to the new temperature. Okay. So this involves specific heat capacity. This area is going to involve specific latent heat because there's no change, and region 3 again involves specific heat capacity. And here, where it cools off, involves specific heat capacity. So if the temperature increases or decreases, like in regions 1 or 3, it's specific heat capacity. If there's no change in temperature while heat energy is being added, that's specific latent heat. Okay, so let's get a bit more specific.